Hello and welcome to my talk. You'll probably have noticed, if you've got keen eyes, that the title here doesn't match what was on the splash screen. This one here is missing my beloved Oxford comma. So I'm going to just slide back some of this text here and make some space for a comma that I happen to have an extra in my pocket, and I'm just going to fling it up there and put it back in its place. Much better. I feel much more comfortable about this presentation already, so please join me as we continue on. Today's plan is to cover 3 different main points. The first one is to tell you a little bit about who I am. The second point, B, is to provide you with 4 different tips out of a bag of many more, but 4 tips that I think have been very useful for thinking about how to engage with students in an online world of educating, teaching, training, and learning. And then finally, point C, to reflect on how's it going anyway? So let's get started with the first piece. First of all, my name is Tarmo Ramel. You may think, wow, that's a strange name, and you wouldn't be the first one. So I've made it a little bit easier for people to try and remember my name. On the left, we have a picture here of a road or a driveway, something that we put tar onto to fix the cracks. So if you think about tarring your driveway, and on the right-hand side, we have our favorite picture of lawn mowing, which is the worst task I can imagine. It sounds a lot like the end of my name. So if you take tar your driveway and mow your lawn and you put them together, you get Tarmo, and you're probably not going to forget my name for an awfully long period of time. I'm also a geographer. I used to teach in the Department of Geography. We are now the Faculty of Environmental and Urban Change, but I am a geographer and I study the Earth, I study the planet, and I do that with geomatics, and we do all kinds of high-tech measurements and characterizations to understand and to think about how our Earth works. I'm also a remote sensing scientist, and I spend a lot of time analyzing and interpreting and coming up with methodology for doing that to understand what our Earth is all about by looking at satellite imagery. So all of this requires computing, it requires technology, it requires field methods. There are many things that are much easier to teach and to experience when you're physically in a classroom or in a lab or in a field setting. To bring all of that to a student through the internet has significant challenges. So my first tip is to make simple illustrations and animations. These can be used to really take home the message of very complex ideas, concepts, phenomena. I have here 3 different small animations, and each one describes a very specific mode by which an aerial platform may change its orientation. We have roll, we have pitch, and we have yaw. And these are terms that you may or may not be familiar with, but the simple diagram that shows the aircraft tilting from side to side, roll, or its nose dipping down and coming back up, pitch, or yaw, turning left to right, allow you to understand and conceptualize what these terms mean and how we might understand them when we're talking about the motion of a satellite or the motion of a drone that's collecting imagery for us for some of the high-tech work that we're doing. So I really try to use visuals and animations to bring complex concepts home to the students. Tip number 2 is sometimes an animation isn't necessary. Sometimes we just need a really good diagram. Maybe we need to know what's inside that drone. So I'll take really good photography that zooms in on the thing of interest, and then I will use labels to point to things so that people can spend time looking at the screen and figuring out where things are. We take this and then later build on it in terms of, well, do you remember on this figure when we looked at the motor or the controller or the battery? And we can expect that students now have a reference that they can go back to when they can't remember where these things are or how they fit together. So animations is one thing, but well-labeled diagrams and large diagrams so that everything is clearly visible, really, really important. The third piece is going beyond the basics. What I really try to do is put myself into the presentation. Here I am. This is what I look like. But my hand motions, my pointing, my inflection, my responses to what I'm saying help convey the message to the audience. So as a student, you get the experience of me actually teaching to you rather than me hiding in my pajamas in the corner of my room, simply speaking onto a recording. So let's take a look. So welcome to Geography 2340, Introduction to Geoinformatics. This is going to be my home studio where I come live to you. Well, not really quite live, but we're going to be giving our lectures and our talks from here. And as you see, this background is kind of boring, so let's fix that a little bit. Much nicer. Anyhow, oh, and it is COVID, as you can see. We have this spinning virus hanging around, so let's get that out of here. We don't want that in our courses, and let's get started. So that rotating virus, that was a lot of fun, wasn't it? I blew on it and everything, but it's still around. I don't get it. This is where I would put in a laugh track because I just dropped a great joke and nobody was here except my studio lights to laugh at it. So we can make things a little bit more lighthearted and take from sitcom tradition and just throw laugh tracks in and make things a little bit more enjoyable as we go on. And the fourth tip that I have for you today is to keep it real. We all misspeak, we make gaffes, we do something stupid, and in a lecture room, we compensate for it, we correct that mistake, and we move on. So I have an example I'd like to show you in just a second where when I'm teaching, sometimes I'll throw these in, not because I really forgot what I was saying, but because I wanted to draw attention to something that was really important. And I played up this whole idea as forgetting something. Take a look. And it's calculated by taking the, oh, I seem to have forgotten the calculation. Hold on. I'm going to call our prof. Hey, Tarmo, how do you calculate NDVI? Oh, hi there, Tarmo. That's pretty easy. All you need are two pieces of information. You need the near-infrared reflectance, and you need the red reflectance. Ah, okay, thanks. So there you go. It's like phone a friend, and you get help on demand. Works really, really well. And finally, point C, is it working? I'll tell you one thing, it is a ton of work. And I was doing this primarily because I figured that if I did it now and I got through the pandemic, I might be able to use some of this content to teach these courses online or in a blended or in a flipped classroom format in the future. So I'm sort of hedging my bets that I can use some of this material again. But I think that the students like it. I really want to be there and teach to the student rather than just having them consume content without me being a part of it. And I think that's the value added component that we add when we do this well. I'd like to thank you all for coming today or for tuning in, and I hope that something here will resonate with you. If you have any questions, my contact information is on the next slide, and by all means, contact me if you're so interested. Have a nice day.